Hello and welcome to another webinar from Epever. Today we will talk about the Epever's hybrid inverter charger named UPOWER HI. And in our previous webinar series, we have covered the former product called UPOWER. Today we will cover the basic principles of a hybrid inverter charger and with a focus on highlighting the main characteristics and features of the high series of this line of products. So, as usual, we will shortly introduce the UPOWER HI and we will check some key characteristics from the datasheet. More importantly, we will check the working principles and the block diagram of a hybrid inverter charger. We will then check the features, connections, and control and display functions. Then we will discover the working modes of UPOWER HI. And finally, we will have some short notes about the applications of this product. So, as you already know, a hybrid inverter charger is a device which combines the features of a charge controller and inverter. A hybrid inverter charger is normally chosen when there is a possibility to get energy from grid and external power generator. So this unit is capable of getting energy from external power providers, not only solar panels. In general, UPOWER or UPOWER HI will not only charge the batteries by solar energy, but will also charge them using an external AC source. And it actually features multiple charging and output modes to meet the different requirements. We will explore these modes today. And it brings high reliability, stability, and quality of energy to the users of grid applications. We will have a quick overview of the efficiency and the quality of the power provided by UPOWER. Well, UPOWER HI has a 4.2-inch LCD display, and it provides several working parameters of the device, such as PV voltage, the battery voltage, the load voltage, the current versions of these parameters, and so on. It also demonstrates on a visual interface the path of energy from different components of the off-grid solar energy. Thus, you can see, for example, if the energy comes via a DC source or an AC source, and also where the load is getting the energy from. UPOWER HI gets connected to remote battery voltage and battery temperature sensors. And this helps to be more precise and to provide a healthier charging profile for the battery. And also the dry contact provides means to start and stop the external power generator automatically. So this is connected to an external power generator, and this function helps to save the fuel and costs by running the generator only when it is necessary. And via Modbus RTU protocol, you can access all these information and the modules like 4G module or Wi-Fi module, which provides remote access to those parameters or a cloud access. Also works based on Modbus on an isolated port. So this communication port is actually protected and isolated. And in general, you can monitor this device remotely or via cloud. And UPOWER HI can be connected to lithium battery which usually comes with Battery Management System or BMS. BMS protects the battery, for example, from overcharging, over discharging, or charging in extreme temperatures and so on. So UPHI is compatible with BMS for lithium batteries via Modbus. For example, it reads the battery voltage directly from the BMS. And this is very common in battery brands like PylonTech or I don't know, Meritson or Narada, Foxes, and a lot of modern lithium batteries. It's also good to mention that the UPHI turns on with external AC source, so it will not require a battery to be turned on. This is totally a different architecture from the previous series, which was UPOWER. And this means that a dead battery does not mean no charging. You can actually get the device on by having a external AC source like the grid and power your consumers via that. You don't need a battery for that. So here you can see the connections for the utility and generator. AC output is also provided here, and then the battery negative and battery positive terminals. And displays here can be used for the cables such as BMS cable, remote temperature sensor, or remote battery voltage sensors. And then here we have the solar input ports with the MC4 connectors. Okay, what you can understand from the name of the product. Okay, UP is actually the name of the series, and H stands actually for the high series. And this is the power of the product. And then M here stands for PV tracking technology, which is in this case the MPPT tracking. Actually, these two numbers are the battery charging current and the battery voltage. So in this case, we have 80 amperes of charging capacity for the battery, and we have the 48 volt system because 4 stands for 48 and 2 stands for 24. And then we have two output voltages. One stands for 110 and 2 stands for 220. And and this is configurable. And the last three letters are for display customization. So a display module could be a black or white display, which is on the standard models, or it could be a colored display or TFT LCD screen. It also could include the letters such as RTU, which shows that this UP has a 12 volt power supply for the cloud monitoring module. And in general, UPHI is competitive in the market, both considering the technical aspects and also the costs, which makes this really popular product in the market. And in less than 1 year, we have manufactured, I think, over 5,000 pieces of UPOWER HI, and they are all running in the field now. So let's have a quick look at the parameters. So as you can see, UPOWER HI supports both 24 and 48 volts battery system, and the charging capacity actually could go up to 80 amperes in UPHI 5000 model, and the continuous power is clear. Then we have this surge power. The surge power is normally double the capacity of continuous power. However, in some models like UPOWER 5000s, the surge power is limited to 8 kilowatts instead of 10 kilowatts, and it is a restriction derived from the power MOSFET. And it is highly recommended not to put the system on its full capacity. This means that if you're running a 2K load or 2 kilowatt load, it's better you go with the models with higher continuous power capacity like 4 or 5K models. And the output voltage and frequency and waveform are also demonstrated. And the customer can choose it based on the residential appliances voltage. And the load power factor and the THD is also mentioned. THD, or total harmonic distortion, is the cumulative degree of distortion within an electrical current compared to the ideal. And normally, with low power factors, the amount of non-working power within a given load is a large proportion of total apparent power, so that the quality of the power is largely affected, for example, with the inductive loads. And power factor is described in our previous webinars, so you can quickly refer to it on our YouTube channel. And the efficiency is reasonably high, not as efficient as individual modules. So if you look at a single charge controller or a single inverter, you will find higher efficiencies. But there are reasons why the efficiency of a hybrid device is less than the individual components. We will cover it. And as you can see, the utility voltage and frequency range is also wide enough to cover all the deviations that might happen in your network. The PV charging characteristics is also demonstrated here. It's also nice to know that the surge current here actually is intentionally kept low. So that's because UP High is lithium friendly. And since the lithium batteries come with a BMS, in case of high current demands, the BMS will shut the output down, which is not good because it means interruption in the power. So UP High keeps its surge current limited to be able to work with BMS systems. And it should be noted that the surge capacity remains for 3 to 5 seconds. So depending on the model, which is considerably actually a long duration, 3 to 5 seconds. So this could be even higher, but this is not good for lithium batteries. And we have a separate circuit for that to enable the system to get coupled with the lithium batteries. And we will discuss that in the coming slides. And then the information for self-consumption level, operating temperature, dimensions, and so on is available. And it should be noted that no load means when PV and utility are not connected. No loads are connected, but inverter is still on. But with the standby, the inverter also goes off. That's why the no load consumption is slightly higher than the standby consumption. And you can refer to our website for detailed information about all the models. Okay. So now here we see a very simplified block diagram of a hybrid inverter charge. We have different components here. We have the PV, the solar panels, we have the battery here, the storage system, we have the inverter, and we have the grid here. So what happens actually, there is a booster circuit which boosts up the PV voltage to a high value, and this is distributed in a high DC voltage bus. And the high voltage provided here is being used with two components mainly. One of them is bidirectional DC to DC converter, and the other one is a bidirectional high voltage DC to AC converter. And then, if you can see here, these are bidirectional, so this can provide a voltage to the bus or use the voltage on the bus, and this is the same for here. So a simple scenario could be the PV charging the battery. So the PV voltage, which could be lower, gets amplified to this bus, and then a DC to DC converter is used again to convert this down to charge the battery. Or this can be also interpreted like this, that when the battery is providing energy to the loads, so the battery provides the voltage in the low side, it is boosted up to the high DC voltage bus, and then this module here uses that high DC voltage, and using the SPWM technology, it provides a sine wave output in the output section. Or again, a grid can be converted to DC and then converted to high DC and again to low DC and could be charging the battery. So the key concept of using a hybrid device is actually on these two modules, which is the bidirectional DC to DC converter and bidirectional high voltage DC to AC converters. So, okay. So let's have a look at the interior parts of the UP Hi. So the first one is the Modbus communication interface. And this is the connections for Modbus converter, which is also isolated. And this is actually a RJ45 connector, the typical Modbus connector for Epever products. This converter is also connected to the LCD in front of the panel of UP Hi, and actually you only see the connectors and the PCB is actually on the board. And the top PCB here is for the IoT module, and the IoT module itself is connected to RS485 interface as well. So this is acting like an like a hub, and BMS is also connected to this hub. So then we have the battery anti-surge, anti-reverse protection. We will discuss about the battery protection functions. For now, you can see the PCB here. And then we have the edge bridge in low voltage side. And then we have the PV boost circuit. As you can see, this is a kind of separated board itself and is not combined with the main board. We had a good reason for that. And then we have the DC to DC converter here, this module. Here is the MCU, or the brain of the device, and all the current sensing, voltage sensing, pulse width modulation commands, and all the control signals are generated in this module. And then we have the edge bridge in the high voltage side. And finally, we have the edge bridge at the AC bus and the PFC filter here. So this is in general the whole components of a hybrid inverter charge. So with all these switchings and high current elements, the PCBs will get warm. So users have to be careful about the temperature while designing and using the system. Normally, it is actually advised to decrease the power 100 watts per every centigrades of temperature between 30 and 50 for this device. And this ensures a safe operation in high temperatures. and decreases the power loss due to the heat generated in the PCBs. So one could easily notice that choosing the UPOWER HI with double capacity, or in another word, running UP High in its 50% capacity, will ensure you will remain on the safe side when you are talking about the performance, or I don't know, the power quality or the power capacity. So, and of course, if the temperature goes too high, the protective functions will shut down the inverter and until it reaches the acceptable temperature range, and then it restarts again. So then we can have a look at different features that this device has. It supports both lead acid and lithium batteries. It has the battery anti-reverse and anti-surge function, which makes it suitable for lithium batteries. It has maximum battery charging current and discharging current settable, so you can set it. Then we have the advanced MPPT technology with a high, efficiency for charging the battery via panels. And then we have the advanced power factor correction technology, which provides a higher PF for the AC input. We have the utility charge current settable and advanced SPWM technology, which is a technology for providing a pure sine wave in the output. We have a closed loop voltage and current, so we will see what it means and what is the application of it in the coming slides. It also has some safety and quality certificates. It works with different modes. We will check how the modes are working. And it has the interfaces and displays. And what is really important is that it has a self-learning function for SOC. SOC is a state of the charge of the battery. And this is the first Epever product that measures SOC based on the charging and discharge profile, not only by battery voltage. You are not allowed to discharge the battery when it reaches the LVD or low voltage disconnect voltage. So the SOC will be 0% at this point. So when you hit the LVD, this is recorded as the 0% capacity for the battery. And when you hit the float voltage, which is the voltage that the charger will stop charging the battery, we can say that it has 100% capacity. So this way you are always calibrating the state of charge. And on every 5 seconds, UPOWER HI samples the voltage and current of the battery, and the amount of the current going to the battery decreases as it's getting charged. So UPOWER HI sums up the current that goes into the battery and comes up with a cumulative number in amps hour that reprojects the actual capacity of your battery. This way, if the capacity of the battery decreases by time because of the aging, no matter. Your SOC is being calibrated per each charge and discharge cycle. So this is really a fantastic feature of the UPOWER HI. So we have several protections on the PCB as well. We have protection against PV reversal, utility over voltage and under voltage, battery over voltage, over discharge, anti-surge and anti-reverse, and output overload and short circuit. Okay, let's see how this anti-surge function works. So we talked about limiting the surges in the current so that the lithium battery's BMS will not be activated and the power will continue. So there is a PTC element implemented on the positive junction of the battery with the low voltage converter side, actually. And the PTC stands for positive temperature coefficient. And the PTC thermistors are resistors with a positive temperature coefficients, which means that the resistance will increase with increasing the temperature. So when you turn the system on, this is the moment, there would be a demand for high current. And by passing the current through this PTC, its temperature will rise and resistance will increase, and the amount of the current drawn from the battery will remain in a limited level. This happens really quick, a few milliseconds. And after this phase, there is a MOSFET in parallel with this PTC, and this acts like a switch. And when this switch closes, the PTC will be short, and it's like just a wire here. And once the PTC is passed, now the capacitors on the high voltage DC side require a high amount of current. And yeah, so the capacitors on the high voltage bus will start to charge, and this also demands a peak current of about 77.7 amperes. And for this is for this specific experiment. So there is a lag between the two current demanding processes. If you add them up, that's a huge number, right? But by providing this trick and this lag between those two currents, then you can solve this demand for high current and let the lithium battery work with your system actually. So this was about the Antisearch battery function. As mentioned, the amount of the current is user settable, and this user can set the maximum charging and discharging current for the battery. So in this figure, the red curve is the default curve. So you can see, for instance, it has a limit for cutoff in I5. And you can adjust this value, this limit, to this curve, the blue curve, with the new value, which is I2. So the application is when the load demands high current, when the threshold you defined here, the UPOWER will shut the inverter down. And this is the limit that you can define to the system. Of course, there is a 5 amps added up to this value. But anyway, you can define where your system shuts off the inverter to stop, draining power from the battery or other components of the system. You can play with your limits and charging and discharging profile, and also when the inverter output voltage goes below a certain level, it kicks in the external charger. And of course, when the battery cannot power on, the utility will kick in. Okay, battery mode and non-battery mode. This is quite clear. So UPOWER HI will work without battery, and that's to provide AC output from the DC input of the solar arrays, regardless of any storage system. Thus, inverter module works independently than the battery and provides AC output directly from the solar panels. And you can, of course, have a battery connected, but you can set the UPOWER HI to no battery mode. This is configurable. So basically, if you have only a solar panel in your system and your consumers, you can use the system. Most of the times, for example, this could be used for watering, watering projects where you don't want to spend money on the battery, but you still want to use the functions of the inverter. So you can use that. Or when you want your heavy loads are running during the day and you have very limited load during the night, so you can always have a very small battery. You can put it on the no battery mode, use the sun energy to power your loads, and then at night you can change the mode to use the energy stored in the battery. And in no battery mode, the utility assets only when solar is not enough to support the load alone. And the voltage should be higher enough, for example, 80 volts or 120 volts for a 3K or 5K inverter. We have different charging modes, and we will discuss all of them. So for the battery, we have the solar priority, and utility and solar priority. And for the output, we have the inverter priority, utility priority. And we will exactly check what each one means and how it works. And if you remember, we had a switchover circuit. We talked about it. This switchover circuit had to switch for the AC output between the inverter and the utility. So the transfer time is, in any case, is smaller than 15 milliseconds. Modern computer and computer-related power suppliers can ride through power outages as long as 10 to 20 milliseconds. So depending on the power and the type of the computer, this will pass the power outage criteria for computers. For other types of load, like residential consumers, this is really quick enough and nothing will be interrupted. And we have, so if you can see in the curves, this transition really happens very high, and this peak is not zero. So there is still a power, and the chances to keep the consumer live is too high, depending on the power. And again, we have the same here. We have like this distortion in the signal level, but anyway, we have the power here while transferring. And we also have this multi-stage battery charging. This has been covered in our previous webinars, so you might already be familiar with this function. Just a very quick overview. At first, we are charging the battery with the current voltage level. So with the current, with the limited current level, so the voltage of the battery increases, then the amount of the current going to the battery decreases and the voltage is kept constant, and then you have the float charging level until it reaches 100%, and then if you consume the battery, then it will go down and the process will be repeated. And there is an argument that the lithium battery doesn't need the float charging state. Well, that might be true, but you can always play with these settings here. If you set the float voltage lower, then you can skip the float charging stage for a lithium battery very easily, just by configuring the parameters of your system. And we mentioned that we have a high PFC for UPOWER HI series. Actually, the power factor correction, which is being done with several technologies, shapes the input current to be synchronized with the voltage in order to maximize the real power drawn from the UPOWER HI. And in a perfect PFC, the input current follows the input voltage, and like as a pure resistor, the voltage is synchronized with the current without any harmonics. So in here, you can see that the current wave and the voltage wave, which are the yellow and the blue ones, they almost overlap. And the power factor of 0.99 is associated with this experiment, which is, which shows that this is high enough for a hybrid inverter charger. And here in left, you can see the output waveform as well. So thanks to the advanced SBWM technology, we have a pure sine wave output. Sinusoidal PWM is a typical pulse width modulation technique, and in this PWM technique, the AC voltage reference is compared with the high frequency triangular wave in real time to determine the switching states for each pole. So we had a lot of switches in our system. And on the right hand side, also you can see the inverter overload protection. And once the demanded load exceeds the defined limit, the UPOWER HI shuts down the inverter automatically. So this is again happening, turning on, it automatically shuts down, automatically shuts down, because the load connected to the UPOWER HI is high enough. So dual digital voltage and current closed loop controlling. Well, this actually ensures that there will be a supreme overload handling. So we had a closed loop control over the output voltage and current. So this is the output side. If you get the samplers here with for the voltage in parallel and for the current in series to the circuit, if you get enough samples, you can have a control over the output of the inverter. So in the right side, you can see an example of 8.5 kilowatt load, which is an air conditioner being powered by UPOWER 5000s or 5K. As you can see, when the air conditioner has been powered on, there is a huge demand for current at the first moment. So the current starts to fluctuate in a switching manner so that the device will not shut down, but we also do not have a continuous rush current on the circuitry. So this is a trick. We're trying to keep it limited. And this way, we can handle the current demand, keep the device on, and successfully pass the rush current demand phase for such a huge load, which is 8.5 kilowatt, AC consumer. This is thanks to the closed loop control of the output voltage, and the current is in here. So whenever the current is going too high, we can sense it. MCU says, hey, limit the current, and we do that. The current goes down and up, and with this fluctuation pattern, we could actually not only turn on the device successfully, but we could also keep the current amount limited in a way that we can still work with a lithium battery. So you can set the parameters of your system. This could be done with the LCD. We have two sets of parameters, the common user settings and the engineer settings. You can set the common ones by long pressing the set button, and the engineer settings by long pressing the up and down buttons. It could be anything. It could be the LVD, it would be voltage disconnections and voltage reconnections criteria. So you can just set these parameters using the LCD itself. And as mentioned before, you can monitor the device via cloud. And for this, you will need an IoT module. And the isolated RS485 module only provides 5 volts so that the power short circuit would not damage the port. However, for a 4G module RTU, you will require 12 volts, and a customized UPI is indeed needed to provide this power. And as you might remember from the names, we had the RTU, which is standard for the UPI that also powers the IoT module. And of course, there are sets of parameters to this unique Modbus device. Well, you cannot set the baud rate, but you can set the Modbus address using any third-party generic COM port tool. And we also have a BMS link module, so you can connect the BMS to this module and get this module connected to the system, and that will help you to get your battery connected to your system via Modbus network. We also talked about the SOC reading, the self-learning algorithm, so I will not cover it here. You can always refer to our website for the range of the certificates that this unit has. It comes with the IEC 62109, the EMC, IEC 61683, and ROHS. And you can see the connections here. The order of the connections is also important. So with grounding, you should be very careful. We have enough data about the grounding in the manual for UPOWER HI. Then we have the batteries. Normally on a positive terminal, you have a fuse. And then you have a kind of breaker, a DC breaker that combines the positive and the negative terminals together. Then you have the solar panels. Of course, you need to connect it through the DC breaker, not only to protect it, but this makes it easy to maintain the system. And if you want to make any changes on the solar PV arrays, this is the best choice, just to cut off the DC breaker and do the maintenance job. And then we have the battery monitoring devices like the battery temperature sensor or battery voltage sensor that could be connected to UPOWER HI. We have the utility coming through a breaker to our system, and we have the loads, and we are powering them through a breaker again. So wherever there is a consumer that could harm your system, it should be protected. And yeah. You can also have the external surge arrestors in the system to protect your off-grid system. And the order is important. You can go to 1 to 6 when installing the system, and 6 to 1 when you are, disconnecting the system. And as mentioned, the temperature compensation coefficient is locked to 0 when the battery type is set to lithium or BMS communication is established. And the remote battery voltage sensing has anti-reverse protection. And why you would need that? Because in long distances you will have voltage drops. So if your battery is in a long distance with your hybrid system, then you will not be able to sense the voltage correctly. For example, if the voltage is, for example, 47, due to the voltage drops in the power lines, you would sense 46, and this will, harm your batteries because you are never able to read the correct voltage. So the SOC will not be correct, and yeah, you will be in trouble. So it's better if you have a long distance between the battery and the system. It's highly recommended to have the battery voltage sensor there. And of course, we have a dry contact, which can be set to automatically turn on or off the generator. This capability also comes with generators as well. And what I would like to discuss now is the working modes of UPOWER HI. This is commonly confusing because, yeah, if you want to write it on the paper, each mode will take a few pages to fully cover it. But with the animations, I think that would be easier to understand what is each mode. So for the first mode, we have solar only and inverter priority. What does it mean? The first column is talking about the battery. The second column is talking about the load. So when you have solar only for the battery, you are telling to your system that only solar panels should charge my battery. And you are saying that inverter priority for the load, you are telling to the system that you prefer that the inverter provides the output to the load. So let's see what's happening. If you have enough PV power, then it will charge the battery, and the inverter will have access to the high voltage bus to convert it to AC and power the load. But when the PV load is not enough, then your battery will be started to be consumed, and it will reach a level that the inverter will shut down, and it will not be able to provide the required energy to the load. And at this point, the inverter is disconnected. Then if you have the utility present and the solar panel is not enough, the utility will run the loads and the solar panel will charge the batteries. That's all about it. And then we have the other mode, which is the second mode, and this is solar only, which you already know what it is, and then utility priority. In this case, if you have enough solar panel, enough solar energy, it will be dedicated to charge the battery, and the utility will provide the power for AC consumers. If you don't have the utility, the solar panel will charge the battery and provide the output power. And if you don't have enough solar power, the battery will start to discharge, and at a certain level, it will be cut off, the inverter will shut down, and the solar panel will only be able to charge the battery until it's going to LVR voltage or low voltage reconnect voltage. Then we have the solar priority mode. So you say that it's prior to me that solar charges my battery, and inverter priority says that my priority is that the inverter provides power to the consumers. So in case that you don't have enough PV power, the battery will be consumed, and it will reach to a moment that the voltage will be low enough, and it will not be able to provide the power to AC consumers. So the battery and the PV will together charge the load. And well, if it is also lower than a certain amount, and you have access to the utility will provide power, because it's not utility only. It's not inverter only. It is inverter priority. So when the inverter cannot be run via the battery or the solar panel, the utility will come and charge and provide power to the AC consumers. And of course, when you have enough solar energy, then you will not only charge the battery, but utility together with PV will provide, or the inverter together with the utility will provide the power to the AC consumers. And when the utility is abnormal, again, it will start to power the load, and the battery will be consumed, and after a certain point, it will be only enough to charge the battery. And then we have the solar priority and utility priority. So the solar charges the battery, utility provides power in the output. And if you don't have enough solar power, the utility will actually help to charge the battery. And then, if you have enough PV array available and enough utility available, both the inverter and the utility will help to power the consumers. And if you don't have the utility, then the PV will charge the battery and inverter will provide the power at the output. And if it goes down, the same story happens. And at a certain point, the voltage of the battery will go down, and only the battery will be charged and the inverter is shut down. Then we have the utility and solar. So the utility and solar will together charge the battery, and inverter will provide the output. And if you don't have enough PV, then the utility will provide the output for the load. And if you don't have the utility, again, inverter will be working. And if your solar power is too low, then battery will be consumed, inverter will be shut down, and the same story will happen until this battery gets charged and reaches to the low voltage reconnect voltage. And then, the inverter will be turned on to power the AC loads. And finally, we have the no battery mode. And this way, it goes directly from the solar panels to the inverters. And if you have also the utility, it will also help to power the consumer. So these two together will provide the power required for running the AC consumers. And if you have low PV power, then the utility will be bypassed to the AC output directly. And together with UPOWER HI, you will get sort of accessories like the ring connectors for battery connections, the isolated tube connectors for the AC inputs and outputs. Then you have an extra fuse to replace the battery positive terminal fuse. Then you have wrench for battery connections and some bolts for fixing the UPOWER HI in the fixture or the wall. You have the MC4 connectors for solar panels input, and then you have a thermistor or temperature sensor for sensing the environment's temperature. You can also get some external optional accessories like the remote temperature sensor, Bluetooth module, Wi-Fi transmission terminal, the GPRS, RS485, and BMS protocol converter with that. And finally, just a few notes about UPOWER HI, about installing and using it. Do not install in a humid, oily, full of dust or explosive gas environments. Keep good ventilation and dissipation. Do not connect battery whose types has not been mentioned in the UPOWER manual. If you do, you need to configure it. And you cannot, of course, connect all types of it. Do not connect battery whose voltage is out of the range mentioned. It will either damage the device or the device will not work. Recommend to connect battery fuse or circuit breaker with 2 times higher than the rated discharge current. Install external lighting arrestor. I would recommend always, not when it's prone to lighting. As an off-grid user, you should always be ready for transients, like peaks in voltage, peaks in current, lightning, and whatever. You should be prepared for that. And trust me, that is much more cheaper than getting a device damaged because of the transients. And you need to rate your power according to the criteria that I told you. Only 50% capacity would suffice. Do not connect multiple devices in series or parallel. You cannot parallel them, at least at the moment, maybe in the future, but now they are not able to work in parallel together. And do not tie the output of the grid, output to the grid. This is not going to feed energy to the grid. This is not a grid tied or grid connected or on-grid device. This is an off-grid device. Turn on loads one by one. First the heaviest one and then the other ones. That makes sense. And please do not touch the device at least 10 minutes after powering the device down, because the energy stores in the inductors and capacitors might be really harmful.